Hi everyone, thanks for your coming today. My name is Chao. I'm a QA engineer from Taiwan. Currently, I'm working on Selenium project, which is a new project launched in February this year in Taiwan. And I'm in charge of test automation for web UI and API. Today, I'm here going to talk to you how we do parallel Selenium test for web UI with Docker containers. Before we get started, I would like to know how many people here are also using Selenium. Would you please raise your hand if you are also using Selenium? Oh, thank you. It seems many of you have experience with Selenium. Then, I hope today's talk will bring you some different ideas about software testing with Selenium and Docker. Before we start it, I would like to introduce you our team members in Taiwan. We have 12 members in QA team, and we are in charge of test automation and manual test for 3 projects: Line Now, Line Today, and Line Taiwan EC project. Here is the agenda today. First, I will give you a brief introduction of why and how we use Selenium to automate web UI test. And then I will show you how we make a disposable test runner container for web UI test. Lastly, I will show you our experience with parallel Selenium test with Docker Selenium Grid. Web services are everywhere. As you may know, the most popular products in line are associated with mobile. But the system behind those mobile apps are also supported by different web services. For example, Line Now is a location-based service for group events, such as wedding or a concert. By integrating Line chatbot and the beacon devices, the service provides users significant experience in group events. The service consists of 3 web applications. First, the system for internal users called Content Management System, which provides features like creating and managing the relationship between events, beacons. For the external partners, there is another system called External Management System, which provides limited functions and that our partners manage their events in the system, such as creating activities of the event. We also provide a web page called Party Manager, which is designed for the event host to manage the activities and control the flow during the event. Let's see our test strategy in web UI for those different web applications. The test scope can be divided into 3 levels: functional, integration, and end-to-end level. The test scope in functional level is the minimum function provided by the system, such as creating an event in the content management system. In integration test level, the test is between more than 1 component. For example, after creating the event in the content management system, our external partner will be able to see and modify it in the external management system. In end-to-end test level, we want to verify the scenario from the users of fields. According to the business flow we designed to the product. The test scope here covered mostly components in the system. Since the quality is the most important thing for us, and we do also want to release the product rapidly with high quality. Therefore, how to speed up the test cycle became a major problem. Selenium is an open source project for supporting the automation of web browsers. Selenium WebDriver API supports all major browsers on the market, such as Chrome and Firefox. Selenium WebDriver API drives a browser natively as a user, with either locally or on a remote machines, by using the browser's built-in support for automation. WebDriver is an interface to write instruction sets that can be run interchangeably in many browsers. WebDriver controls browsers that are running in other processes, which means that every API call is a remote procedure call. And therefore, the performance of the framework is at the mercy of network latency. As the network latency between the browser and the test code increases, it may have seemed inefficient. Since we used Selenium to automate hundreds of test cases on our projects, from functional to end-to-end level, the more cases we automated, the more time we need to take on execution. The average execution time in each test scope level is from less than 1 minute to more than 2 minutes. So it usually takes hours to perform UI automation tests for hundreds of test cases. So the biggest challenge in web UI test is slow test, because it needs to be inferred by looking at elements' properties in the browser. Also, there are several checks that need to be made to determine whether an element is visible to end user. So, with the test case growth, the test execution time will be longer and longer. Our goal is launch automation tests for every build and send feedback within minutes. So we need to optimize the execution. Instead of performing tests sequentially, we parallel test to get feedback faster. After adapting periodization in regression test, we got 50% decrease rate in execution time. It makes automation tests efficient and led us to find the issues at an earlier stage. Let's see how we made it. Parallel test suite. What you need to consider for running tests in parallel: first, you can use multi-thread library in your test framework. But do not forget to control your data while running tests at the same time. For example, since we are using robot framework in the test infrastructure, there is an open source library of the framework called Paybot. The library allows you to parallel test suite and provides data lock between the executor process. Depends on which test framework you are using. Find a suitable library for running tests in parallel. For Selenium WebDrivers, you can manipulate the Selenium Grid server to handle those multiple test requests in different servers. Selenium Grid allows you to run your tests in parallel. Different tests can be run at the same time on different remote machines. Selenium Hub is the main command center for managing which machines your Selenium test will run on. When you run a Selenium test and pass it some remote WebDriver desired capabilities parameters, it goes to the hub and finds available node that matches the criteria. For example, when the hub receives the request, it will reroute the test to the node server container according to the browser version you want to run against. Now, we got another challenge. If we want to build up this parallel test environment, we need to install so many libraries and set up its configurations on many host machines, either on local or cloud platform. For example, If you want to set up an environment for running Selenium tests, you need to install Selenium library and other required dependencies. Even more, you have to configure the environment variables and the test data in the test runner server. Also, if you want to set up a Selenium-grade server in your test infrastructure, you need to install Java, Selenium jar, browsers, and even VNC server for debugging. It's not easy to scale up if you need to extend the number of node servers for supporting more test requests. That got me thinking, do we have better solution for it? Do we? Container technology allows you to put all required dependencies in the container and ship it to whichever platform your application should be run on. By using container technology in software testing, we can have a flexible and portable test infrastructure for web UI test. Selenium provides APIs to simulate UI flow as users for automation. Docker is the platform for packing the application and running it on anywhere. In the following, you will see how we manipulate Selenium and Docker to build up the test infrastructure for running Selenium tests in parallel. So what is Docker? Docker is an open source tool designed to easily create lightweight, portable containers for any applications. Its target is for developers and DevOps. Applications are packaged in containers and then shipped to whichever platform it's meant to work in. Use Docker, you can build, ship, and run your applications quickly and easily. In software testing, the test runner, just like an application, provides features such as test execution and feedback collection. Let's see how we build, ship, and run the test runner by using Docker container. To build a test runner container image, you have to include Selenium and multi-thread library in your Docker file. A Docker file is a text document that contains all the commands a user could call on the command line to assemble an image. It's easy to be managed and maintained in the source control management system, like Git server. With a simple command, Docker build, it's easy to build your test runner container image consistently. Here is an example to build test runner container in your CI. First, prepare your Selenium test as usual, and define your Docker file with appropriate configurations and test data. Once you commit the code in the repository into the Git server, it will trigger the Jenkins job and build the test runner container image and push it to the Docker registry. Here, we use the private registry for security concern. Furthermore, you can build your test runner container as Jenkins slave. Since there are several ways to launch slave agent from Jenkins master, you can install the daemon or process in the test runner container according to the method against to. For example, if you want to launch the slave agent through SSH protocol, you can install SSH daemon in the test runner container, or you can build with the base image. Docker allows you to build your image start from a parent image. So you can build the test runner container with the Docker image, such as Jenkins slave. In this base image, Java and SSH daemon will be installed, and Jenkins slave permission is configured. So the next question, how we put it in the CI pipeline. Here, we manipulate a Jenkins plugin called Docker plugin, which used Docker host to dynamically provision a slave. After installing the plugin in Jenkins, you can configure your Docker environment and the Docker image in Jenkins master. Then, by assigning the Jenkins job running in the container as Jenkins slave, once the job starts, the master will communicate with the Docker host through Docker Engine API, and then pull the latest Docker image from Docker Hub or private registry. The Selenium test will be executed in the test runner container through SSH command, and the slave agent will collect test result back to the master. Lastly, the test runner container will be destroyed in teardown, so that we can have a disposable Selenium test runner container in CI. As we mentioned, you can put multi-thread library in the test runner container, so that you can send out the multiple requests at the same time. To handle those test requests, Docker Selenium Grid is a great choice. It's easy to set up Selenium Hub and Node servers by running them in containers. Instead of installing Hub and Node servers in multiple host machines, you can install them on a single host machine. Each server can be easily set up by simple command, docker pull and docker run. Furthermore, you can set up your Selenium grid with its extension, Zalenium. Zalenium is a Selenium grid extension to scale nodes dynamically. Its dynamic creates Selenium node by request from the test runner container and destroy it in teardown. What's so great about it is you don't have to create node containers with the fixed number. The hub will create node container on demand and destroy it after the test finished. It also supports video recording and integrate with cloud testing provider, such as Source Lab service. Similarly, Zalenium has hub and node containers at the first launch. What's the difference here is Zalenium will create the node containers with the associated WebDriver on demand. By sharing Docker socket, Zalenium will be allowed to create node containers by accessing Docker daemon on the host machine, so that you don't have to consider how many node containers you have to run on before the test, or the test might be lagged by the number of node containers. It provides a flexible test environment for web UI test. Once the test finished, the node server containers will be destroyed in test teardown. Only the hub container will be remained, and it will be waiting for the test request with small resource occupation. Zalenium increases the utilization of the resource on the host machine. Let's see more details about Zalenium. First, it provides console same as Selenium grid. Here, you can see a list of all the nodes currently running in your grid environment. Also, you can get details of each WebDriver node in console, such as browser version and its configurations. Since each node server is the Docker container init by Selenium Hub, you can get the remote server information of container as well. Second, Zalenium supports the live preview at runtime. In live preview console, you can see the UI test through VNC of each node container. In addition, you can interact with the application in node container via VNC, which makes the test just like running on the local. In Zalenium, it supports video recording and dashboard. The test case name of each video is the WebDriver session ID. So by querying Selenium Hub API, you can get the session ID at runtime. which is really useful for troubleshooting. For example, you can lock the WebDriver session ID and save the video recording when the test is failed. Then you can replay the video for debugging or attach it in your bug report for reference. Let's see how we build up the test infrastructure with the techniques we mentioned. First, add Selenium and multi-thread library in the Docker file so that you can have a parallel Selenium test runner container. Then, with simple command, docker build, to build the test runner container image and use docker push to ship the container image to Docker Hub or your private registry. With Jenkins Docker plugin, you can start the test runner container in the other host machine at runtime, and then execute Selenium test in parallel by using multi-thread library. Selenium Hub server will handle the test request and dispatch them to the node containers. After the test finished, the node containers and the test runner container will be destroyed. Docker is not only for software development, but also can be used in software testing. It lets you build the test runner container with all required dependencies quickly and easily, so that anyone can run the test to verify the system functions either on local or remote machines. There are 3 items in conclusion. First, to speed up the test, you can use multi-thread library to perform Selenium tests at the same time. With Selenium Grid Server, the Selenium Hub will dispatch the test request to the node server containers. Then, by adding Jenkins Slave Agent in container, you can ship the disposable test runner container in the CI pipeline and execute the test via SSH command. Zalenium is Docker Selenium Grid extension, which provides grid consoles for you to monitor which node containers are running on. Since each node container has VNC, the video recording of the test can be found in dashboard for debugging. Selenium provides API to let you to automate your web UI test flow. And the Docker makes your test environment flexible. Try to use Selenium and Docker to build up a flexible testing infrastructure for web UI testing. I would be happy to discuss with you about it more. Please come find me after the talk. Lastly, I would like to introduce you our team members in engineering team in Taiwan, and also give a special thanks to my best partners. And thanks for your attention.